Hey there everybody. This is a video for my advanced geometry class as they prepare for their comprehensive test over the first 2 units, which includes segment addition postulate, angle addition postulate, vertical angles and linear pairs, bisectors and midpoints, as well as what kind of angles you get when parallel lines are cut by a transversal. So I'm going to talk about the geometry, and then you should pause the video to do the algebra, right? Because if it's the algebra that you need practice with, then by all means practice the algebra. And then press play and check the answers, and I will have all of the algebra done after that. Okay, so this first one is a segment addition postulate. It says here, well, I guess it doesn't say that, but you should know because we have points, right? We have 3 points, and they're collinear, so we can make our figure that looks like this. Z is on MB, so M is an endpoint, and B is an endpoint, and Z is somewhere in between. Okay, so now we're able to put in the math, right? And when I say math, I mean the equations. M to Z is 5x minus 1 units long. MB, now remember, MB is the whole entire thing, so we're going to put that over here outside. And then ZB is 12x minus 5. Okay, now according to the segment addition postulate, we can add up these smaller segments and they will give us the length of the entire segment. Okay, segment addition postulate. So now pause the video, do the algebra, come back and see if we get the same thing. I get x is equal to 3. So now that x equals 3, I can answer the question which says, what is the length of MZ? So I'm going to plug 3 back into here. 5 times 3 minus 1. MZ is 14 units long. Okay, number 2, point P is on TB and point B is on, so once again, this is a segment addition postulate. So we have some segment length TB, and U is in here. And then B is on some other segment called UE, which means I need to extend this a little bit and put in E so that we have our tube right there. Okay, and now we have our algebraic relationship. UB is 3 times as long as BE. So UB is 3 times as long as BE. And then it says that TU is 4 times as long as UB. TU is 4 times as long as the segment length for UB. Okay, so notice we have no variables in here. We're going to have to assign some variables. So looking at this, I can notice that the smallest segment is probably BE, right? This UB is 3 times as big, and then TU is bigger than UB. So I'm going to call BE. I'm going to let BE be my X variable. So BE is X, which means UB is 3x, right? 3 times as long. Now here's where it gets harder, because TU is related to UB, right? TU is not 3x or 4x, but rather 4 of these things, 4 UBs. So 4 and UB is 3x. So this is a total of 12x from T to U. Okay, that's the hard part here, is that things aren't just related to x, but they're related to something else that's related to x. And we know the whole thing is 48, so we put 48 over here. And now once again we have a segment addition postulate problem. Okay, and doing the algebra, we get 16 total x's equals 48, so x is equal to 4. And now it says, well, how long is T to B? So now we have to plug 4 back in, and 3 times 4 is 12, and 12 times 4, what is 12 times 4? That's 48. Well, that's too long. Hang on a second, let me think. Haha, I see. Okay, x is not 4, but rather x is 3, which means this is 9. That makes more sense. And this is 36. Okay, so then from T to B, that is going to be 45. TB is 45. There we go. That makes sense now. Okay. R is the midpoint of segment AM. So we have segment AM here, and R is in fact the middle. RM is 3x plus 6, and AM, the entire length, is 7x minus 8. Okay, so notice we're missing a part right here, right? In order for this to be a segment addition postulate problem, we need to have both lengths of the segment adding up to the total length of the whole thing. Okay, which is precarious because we're kind of missing that red part. Well, we know that it's a midpoint, right? We're told it's a midpoint. And if it's a midpoint, then these two lengths are equal. So if RM is 3x plus 6, then this is also 3x plus 6. Okay, so that's the key to doing this problem, is recognizing that both of these lengths are equal. So we can't just assign it a variable x, because x has already been given, so you can't make something new there. So doing the math, we get 1x equals 20. And if x equals 20, a to r is 3 times 20 plus 6, so a to r is 66. Okay, M is a midpoint of some segment AB. So let's see, we'll go A and then B. And we know M is in the middle. Okay, so this is a problem where we're just going to count, right? We're going to count one of these because these are coordinates. We can put them on a grid and we can count. Because if it's in the middle, then the distance I go from the x to x, right, from the end point to the middle, which is 3, I've gone 3 units to the right. In order for that to be in the middle, I have to do another 3 units from where I was. I was at 4. 4 plus 3 is 7. Okay, and similarly for the y, I've started at 3 on the y, and now I'm at 10. Okay, that is 7 units higher than it was before. So I have to do another 7 units up, plus 7, to get to 17, and that's going to be the coordinates for B. Okay, what is the inverse of the following conditional statement? So remember, an inverse is a negation, right? So we have not. So we have if P, then Q. That's your standard conditional phrase. Then we have if Q, then P, right? That's the converse, if Q, then P. And then we have not P, not Q. That's the inverse. And then we have not Q, not P. That's the contrapositive. Okay, so we want the negation of this statement. So we're going to take away the not. So if an animal is scary, then it is not, so right, we're going to add not in here, not a rabbit. Okay, so that is the inverse of this statement. If an animal is scary, then it is not a rabbit. Okay, here we have a vocabulary word called supplements. You need to know that supplements add up to 180. So we have angle G plus angle H equals 180. Okay, so G is here and H is there. So G, 5x plus 22. H is 10x plus 8. Okay, so then we do the math, and I'm going to pause the video so you can do the math. So we'll be right back. We get x equals 10. So if it wants both measurements, we're going to plug 10 back in here. 50 plus 22 is 77 degrees for G. And, no, it's not. It's 72 degrees. 72 degrees for G. And 100 plus 8 is 108 degrees for H. Okay, and sure enough, those both add up to 180. Okay, CD is a bisector of ACB. So we know that this angle got bisected. So this little part and that little part, right? Those two are equal. Well, what do I know about the whole entire thing, right? The whole entire thing is 180. And this much here is 142. So if I subtract 180 minus 142, I know that the rest of this has got to be 38. Because that's what 180 minus 142 is. Okay, so it's 142 to here, and it's 38 to the rest. Well, it got bisected, which means I have to chop both of these in half. So both of these are 19. The question said, what is the measure of DCB? Well, DCB is right here. Oh, DCB is just 19 degrees. Fantastic. All right, what else do we got? Okay, so a bunch of angles that are cut by transversals here. Okay, so vertical angles are anyone that are across from each other. So 1 and 7, 3 and 5, 2 and 8, or 6 and 4, right? A whole bunch of different vertical angles, those that are across a vertex from each other. And then we have some alternate interior angles. So alternate interior angles are, of course, on opposite sides of your transversal, so 2 and 6, and in between your parallel lines. So 3 and 7 also would be a pair of alternate interior angles. And both of those are congruent, by the way, so you'll set the math equal in both cases. Okay, next we have some consecutive interiors. Okay, these are in between your parallel lines and on the same side of your transversal, so there's a pair, they add up to 180. 2 and 3 are a pair, as well as 7 and 6 are another pair of consecutive interior angles. They add up to 180. Okay, linear pairs, there's a ton of them, right? Anytime we have two angles next to each other, that's a linear pair. So 1 and 2, 3 and 4, 8 and 7, 6 and 5, right? Anytime we have angles that are just across just across a line, basically, you have some linear pairs. So there's a ton of linear pairs, 2 and 7, 1 and 8. Linear pairs add up to 180. And last we have alternate exterior angles. Okay, those are ones that are on opposite sides of your transversal and outside of your parallel lines. So 8 and 4 are an example, as well as 1 and 5 alternate exterior angles. These ones are equal, so you have to set them equal if you're going to be doing some math with that. Okay, so now we have some algebra to do, so we want 1 and 4. Now remember, 1 and 4 are consecutive exterior angles, and consecutive exterior angles add up to 180. So we're going to take our algebra, x plus 75 plus x plus 125, and those should add up to 180. Okay, so pause the video, do the algebra, and come back and see what you get. Okay, I got x equals -10. And if we're going to find measure of angle 5, we saw up here that 5 and 1 are equal, right? That's the easiest thing to do. So if we plug our equation back into angle 1, then measure of angle 5 is -10 plus 75, which is 65 degrees. Okay, so angle 3 and angle 7, let's see, where are those? Those angles are right here and here. Okay, so hopefully you know these ones are alternate interior angles. And alternate interior angles are congruent. So we're going to set these two equations equal to each other when we solve this one. Okay, so 3x equals 30 and 1x equals 10. Okay, now we want to find the measure of angle 6. So, does 6 relate to 3 or does 6 relate to 7? It looks like 6 relates to both of them in the same way. They both add up to 180. So either way we slice it, we're going to plug 10 into, let's go into 7. That's easy. I like 10 plus 10. So angle 6 plus 20 equals 180. So the measure of angle 6 would have to be 160 degrees. Okay, so with these problems, there's a couple of things. You have to figure out how these two given angles relate, right? Make some algebra, either add them up to 180 or set them equal. Do your awesome solving job, and then figure out how our desired angle relates to one of the other two angles. Okay, moving on. We know that this whole entire angle from W to X to Y, wherever, X, Y, W is 160. Okay, and then we have two smaller angles. So this is an angle addition postulate. We need to add up our two smaller angles, and that needs to equal the total. So if I add this together, 2x and 1x, well, that's 3x's. 13 and 6, that's 19, equals 160, okay? Because we know the total. We're not setting these equal because we know the total, so we can add them up. So 3x equals 141. And please tell me that this divides nicely. 3 goes into 14 4 times with the remainder of 2. 47. X is equal to 47. So now it says, what is the measure of angle XYZ, which is XYZ right here. So we're going to take our 47 and plug it into there. So 47 times 2, that's 94. 94 plus 6 is 100 degrees. That's the measure of angle XYZ is 100 degrees. Okay, now our last problem. We've seen these ones before, right? We have an X variable and a Y variable. So we have to figure out which ones relate to where and how. So the easiest way is to start with these two because they have the same variable, right? They both have an X in them. And hopefully we know that these are vertical angles. And vertical angles are congruent. So to solve this, we're going to set up our equation. I think this needs to be a plus, I believe. Let's change that to a plus. I think that's what it says on the worksheet. Equals 2x plus 16. Okay, so then we'll bring the x over here, 1x, and then subtract 16. X equals 8, I believe. Okay, so if x equals 8, we can figure out the measure of these angles by plugging 8 in. So this is 32 degrees and, 32 degrees, of course. So now we're looking at these two angles. These two add up to 180. Okay, because they're a linear pair. So our x's were vertical and these ones are a linear pair. So 32 plus y minus 12 needs to equal 180. Okay, so let's see. If we are going to simplify this, 32 minus 12 is plus 20. So y is 160. Well, awesome sauce. Okay, so those are our topics. Those are the algebras that we're going to do all the way back to the beginning of the year with segment addition postulate, midpoints that are equal, midpoints of coordinates like in this one, and then we have some conditional statements, complementary and supplementary, right? Supplements add to 180, complements add to 90. Here we have some angle bisectors with 3 angles that add up to 180. Okay, we have all of our parallel lines cut by transversal stuff. Pretty good right there. Setting up our algebra with our parallel lines cut by transversals. And we have an angle addition postulate and then some vertical angles followed by linear pairs. Okay, and those are all the topics on your comprehensive test. I hope this has been good and you've learned a lot. All right, bye-bye.